Everyone, welcome back to Learning with Haneen. It's Haneen and welcome to part 3 of the Algebra 2 Regents 2024 review session. We are still continuing with the January 2024 exam, and today we will be moving on to the part 2, 3, and 4 of the exam. Just clarification, part 2, each question is worth 2 points. Part 3, each question is worth 4 points, and the last question, part 4, is worth 6 points. And I will be using this video to go over all the questions to show you what you need to do to get the full points. With that being said, if you have any questions, please comment down below. Make sure to like, share, and subscribe. Share with all your friends. Let them know that I'm doing these sessions now so that they can get some review and ask any questions that they need before the test on June 24th. And with that being said, let's get started. And so we're going to start with question number 25, which is question 1 in the part 2 section. And as the instructions say, this section has 8 questions. Each correct answer will receive 2 credits. And so first question says, factor x cubed plus 4x squared minus 9x minus 36 completely. Keyword here is completely. In order to factor this, we're going to split our terms into 2 groups. So we're going to factor this by grouping. We're going to split it so we have 2 groups. We're going to have x cubed plus 4x squared and negative 9x minus 36. So how can we factor this? Well, we can factor out an x squared from here, because x cubed plus 4x squared, what do they have in common? An x squared. So x squared times x would give us x cubed plus, and then 4 times x squared would give us 4x squared. That's the first part. The next part says negative 9x minus 36. What do they have in common? Well, I can factor out a negative 9. So negative 9 times x would give me negative 9x. Negative 9 times 4 is going to give me negative 36. And so now I have these two are common, and I know that's a good sign because that means my factoring by grouping works. And so when I rewrite these are going to be written together. So I'm going to have x squared minus 9, and I'm going to have x plus 4. That's the first part because they're the same, so we just write it once. If you put this on the test, you will not get full credit. Here is why. This part right here that I'm highlighting in red, that is not factored completely. Not factored completely. So you may be asking, well, Haneen, if it's not factored completely, how do I factor it? Well, this, my friend, is a difference of 2 squares, which means that it's going to be x plus factor, x minus a number. Even if we don't realize that, we can always draw the x method. And we're going to, let me just redraw my x. So we know that our a is 1, our b is, there should be no x here. Our b is 0, and our c is negative 9. So we have negative 9 on top and 0. What 2 numbers add together to get 0 and multiply to get negative 9? When we know that's going to be negative 3 and 3. So those will be our factors. So now, factored completely, this following equation or expression, I am still saying because there's no equal sign, is going to be x plus 4, x plus 3, x minus 3, and this is how you'll get full points. You have to show all your work, and you have to state that those are how you factor it completely. Okay? So that is going to be the first question. If you have any questions, write down the question number, ask your question, and I will respond back to you as soon as possible. Question number 26. Determine if x plus 4 is a factor of 2x cubed plus 10x squared plus 4x minus 16. Explain your answer. So we know we have to explain our answer, and we have to determine if x plus 4 is a factor of this expression. And so this question, we can use long division to solve it. And we're going to use long division plus the remainder theorem. And the remainder theorem basically says that if there is no remainder, in the end, we know that this number, this expression, is a factor of the expression that we're getting. So if we solve this through long division and we realize that x plus 4, when we use it as a factor, does not leave a remainder, we know that x plus 4 is a factor. So let's test it out. So we have x plus 4, 2x cubed plus 10x squared plus 4x minus 16. So what times x plus 4 would give us 2x cubed? Well, 2x squared. So that would be 2x squared. So that would be 2x cubed. And then 2x squared times 4 would be 8x squared. And so these are canceled out. So we have we have 2x squared, because 10 minus 8 is 2x squared. And then we bring down our remaining values. So that would be the 4x and the 16. So what times x plus 4 would give us 2x squared? Well, that would be 2x. So 2x times x would be 2x squared. And then 2x times 4 would be 8x. So these will cancel out. 4x minus 8 is going to be negative 4x. We bring down the negative 16. Careful of your signs, because look, a lot of people are going to make the mistake and they're just going to leave it at 12x. It's not 12x, it's negative 4x, because 4x minus 8x is negative 4. This will always be subtraction, like we've learned long division. This will always be subtraction right here. If this is a negative sign, if your number has a negative sign, then it turns positive. If it's positive and you're subtracting, that number turns negative. Okay? So just follow how I did it. 4x minus 8x. Like the way that I did it. 4x minus 8x. 4x minus positive 8x. Negative 4x minus 16. Now, what times x plus 4 is going to give us negative 4x? Well, negative 4. So negative 4 times x would be negative 4x. And then negative 4 times 4 is just negative 16. Again, careful of my signs. Negative 4 minus negative 4 is just 0. And negative 16 minus negative 16 is again 0. And I do not have a remainder. So no remainder means what? Well, that means that x plus 4 is a factor. So we'll say x plus 4 is a factor of 2x cubed plus 10x squared plus 4x minus 16, because using the remainder theorem and solving through long division, there is no remainder left, meaning that x plus 4 is a factor. So no remainder equals factor. Okay? Using the remainder theorem, we can conclude that x plus 4 is a factor because the remainder is 0. Okay? And we can write there is no remainder, remainder 0. You can just add that, meaning that x plus 4 is a factor. Because there is no remainder, because 0 is a remainder, x plus 4 is a factor. I'm going to write it again here in shorter terms and in a different color. Because 0 is the remainder, even if you don't mention the theorem, because 0 is a remainder, x plus 4 is a factor. Because 0 is the remainder, x plus 4 is a factor, and you always want to start with answer. Yes, x plus 4 is a factor. Yes, because 0 is the remainder, x plus 4 is a factor. Always want to make sure you answer that question. Okay? That is number 26. Number 27 says, an initial investment of $1,000 reaches a value VT according to the model VT equals 1,000, 1.01 to the 14, where T is a time in years. Determine the average rate of change to the nearest dollar per year of the investment investment from year 2 to year 7. So let's break down the question. We're given this equation of VT, where T symbolizes the time in year, and the initial value is $1,000. We want to determine the average rate of change, the nearest dollar per year of the investment from year 2 to year 7. So, average rate of change is other words for what? Slope. So we're going to do, before we do slope, what do we need to do? Well, we need to find what the investment amount was at year 2 and at year 7. So what we're going to do is we're going to do V2 equals 1,000, 1.014 times 2. And then V7 equals 1,000, 1.014 times 7. And when we do that and plug it into our calculator, our value is going to be, for V2 is going to be 1,082.8567. And then for V7 it's going to be 1,321.290967. So we found the values for each. Now we do the slope. If you don't remember the slope formula, y2 minus y1 over x2 minus x1. So our y2 is going to be 7, the year 7, and the investment total was 1,321.290967 minus what the investment was at year 2, which is 1,082.8567, divided by 7 minus 2, because this is year 7, this is year 2. And when we do that and we do it in our calculator, we get the rate of change rounded to the nearest dollar to be $48. So the average rate of change of this investment from year 2 to year 7 to the nearest dollar per year is $48. And that would earn you 2 points. 28 says, when 1 over cube root y squared times y to the 4th is written in the form yn, what is the value of n? Justify your answer. So we know we're justifying our answer, so we kind of need to have an explanation, and we need to show our work. With justification, sometimes you don't need an explanation, but it's best if you do include an explanation, just so that it's easier for you to see, just so that it's guaranteed that you're going to get the points. So we know we have to put this in the form yn. So our original form, 1 over cube roots of y squared times y to the 4th. First things first, we talked about this in the previous video. I want to take this and I want to make it into fractions. So we know that our roots is going to become our denominator, and our power is going to become the numerator. So this is going to be written as 1 over y to the 2/3. And I'm multiplying it by y4. So I'm going to do 1 over y 2/3 times y to the 4th. 1. So that's going to be y to the 4th over y 2/3. Rule: when we are dividing exponents, we subtract the exponents. Just as how when we multiply exponents, we add the exponents. So when we multiply two things that have exponents, we add the exponents. When we divide two things that have exponents, we subtract the exponents. So here, we're going to do y. Y stays the same because y divided by y is just y. And our n is going to be 4 minus 2/3. And obviously, we make a common denominator. So that would be, we need a common denominator of 3. So that would be 12 over 3 minus 2 over 3, which would be 10 over 3. So our n equals 10 over 3. That's our n. I'm going to write my justification up here. Sorry that this question is all over the place. So our justification we can say is n equals 10 over 3, because when you rewrite 1 over cube root of y squared, it is 1 over y to the 2/3. And when you multiply, y fourth, you get y fourth divided by y 2/3. And when you add and when you divide, you subtract the exponents and get y to 10/3. 29. 29 says, the heights of the members of the ski club are normally distributed. The average height is 64.7 inches with a standard deviation of 4.3 inches. Determine the percentage of club members to the nearest percent who are between 67 inches and 72 inches. So first thing we notice, it says it's normally distributed, which is a good thing. We can use that. Average height, or the mean height, is 64.7 inches. Standard deviation is 4.3. And our goal is to determine the percentage of club members to the nearest percent who are between 67 and 72 inches tall. Well, if we recall, when things are normally distributed and we want to see the percentage between two something, we can use normal CDF on our calculator. And in order to use your calculator and get points, you need to write all the work that I'm showing you at this moment. So you're going to write normal CDF, and you're going to write, first you're going to write your lower bound, and you're going to label the lower bound. And our lower bound is going to be 67 inches. Then you're going to write your upper bound and label, which is going to be 72 inches. Then we're going to write our mean, which is 64.7. And then we're going to write our standard deviation, which is 4.3. Put this in our calculator, and we get 0.25158. Rounded to the nearest percentage would be 25%. And that is your end of your question. So this would be your answer. You could also draw the bell curve and say, well, this is my mean. And you have 1 standard deviation, 2 standard deviation, 3 standard deviation. And you'll write down the values, and you'll shade in the area where it's between 67 and 72, and finalize your answer using your calculator or normal CDF. Now for question number 30. Question number 30 says, the recursive formula AN equals 6 plus 6n represents the number of seats in each row in a movie theater, where n represents the row number. Rewrite this formula in recursive form. So, recursive form, and so our main goal of this question is to rewrite the following formula into recursive form. And if we look at our formula, we can see that it's plus. So when something is plus or minus, we know that it's going to be arithmetic. So we're going to use our arithmetic recursive formula, which says A1 equals, and then A1, and then we have AN equals AN minus 1 plus D. And so D stands for our common, our common denominator of what is the common term. Let's do that. The common term, or the common rate, kind of. So the common term that is being either added or subtracted. And so, as we said, if we look in our formula, AN equals 6 plus 6n, we know that 6 is going to be our common denominator. And so we're still missing this part, but we have this part. an equals an minus 1 plus 6. So you may be asking, well, how do we find a1? Well, we use the explicit formula. So our explicit formula says we're doing an equals 6 plus 6n. And we want to find a1. So a1 equals 6 plus 6 times 1. Because n is 1, and so we have to substitute n, 1 for n here. So a1 equals 6 plus 6. a1 equals 12. So we know that our recursive formula for this equation, for this explicit formula, would be a1 equals 12, an equals an minus 1 plus 6. You have to make sure that you have both parts in order to earn credit for both sections. Okay? You have to state a1, and you have to state an equals an minus 1 plus 6. And so this is the formula for a recursive formula, or recursive form for arithmetic. Okay. Now question 31. Express 2xi cubed minus 3y squared in simplest form. So we know we are dealing with I, so we want to, first things first, draw our I circle. And so our I circle says we're going to have I0, I to the 1, I to the 2, I to the 3. I0 is also known as I to the 4th. And so with that being, this is 1, this is I, this is negative 1, and this is negative I. Okay? So that is our I circle. Not the perfect circle, but you get what I mean. And this is important because when we simplify and when we multiply, this is going to be helpful to use. So we're going to break down this binomial. Okay, so I'm going to do this in different colors so you can see each part. So 2xi cubed times 2xi cubed. So 2x times 2x is 4x squared, right? I cubed times I cubed is I to the 6. Why? Because when we multiply numbers and they have exponents, we add the exponents together. So these two parts multiplied together would be 4x squared I to the 6. Now we do this part. 2x I cubed times minus 3y. So that's going to be 6xyi cubed. There's no other I term, so we just bring down the I cubed, and then 2x times 3y is 6xy, and we bring down the minus sign. Now let's do this part. This part right here. Well, it's going to be repeated again, and it's going to be the same thing as this term right here. Okay? Then we have our final part. This part right here. Negative 3y times negative 3y is plus 9y squared. So these are our parts of our equation. Now we simplify. So this is going to be 4x squared I to the 6 minus 12xyi cubed plus 9y squared. This is not in simplest form. Why? Because we can simplify our I to the 6 and our I cubed. I to the 6. If we go into our I circle, this is I to the 4th, this would be I to the 5, this would be I to the 6. So I to the 6 would be 4x squared, would be 4x squared times negative 1. Okay? And here, I cubed is negative I. So we have negative 12xy times negative I. And then we just bring down the 9y squared. So when we work this out, and we're going to rewrite this, we're going to rewrite the order. We're going to first write 9y squared Then we're going to write negative 4x squared. And then we're going to do plus 12xyi. This becomes negative because it's 4x squared times negative 1. This becomes positive because it's negative 12xy times negative 1. Careful of the signs. Careful of the signs. Be careful of the signs. And so this form right here would be in simplest form. Question 32. A survey was given to 1,250 randomly selected high school students at the end of their junior year. The survey offered 4 post-graduation options: 2-year college, 4-year college, military, or work. Of the 250 responses, 475 chose a 4-year college. State one possible conclusion that can be made about the population of high school juniors based on the survey. Okay, so we are given that there's 4 choices: 2-year college, 4-year college, military, or work. And the total sample size was 1,250. 475 chose a 4-year college. And so that means that 475 over 125, this would be the 4-year college, would be 0.38, meaning 38%. So that means that 38% of 1,250 students in the sample would choose a 4-year college. Because the sample is representative of the population, we can say that, and we can conclude that the population of high school juniors that would choose, so the population of high school juniors that would choose a 4-year college would be about, so the population of high school juniors that would choose a 4-year college would be about 38%. 38% choosing a 4-year college, and about 62% choosing from the other options. Okay, so let's break down the conclusion that I made. So we found out that the percentage of students in 1,250 who would go to a 4-year college is 38%. And we know that this survey was given to 1,250 randomly selected high school students at the end of their junior year. And we need to make a possible conclusion about the population based on the survey. Well, we can conclude that because the sample is representative, we can conclude that the population of high school juniors that would choose a 4-year college would be about 38%. It's key that we say would be about because at times it might not be exactly accurate. It might be close. It might not be fully 38%. But we also wanted to add that about also 62% would choose from the other options. We could say like whereas, so we know that about 38% would choose a 4-year college, and whereas about 62% would choose from the other options. So now we are in question number 33, and we have entered section 3 of the exam. And section 3 of the exam, all questions will be worth 4 points. So this first question that we get, number 33, says, a researcher wants to determine if nut allergies and milk allergies are related to each other. The researcher surveyed 1,500 people and asked them if they are allergic to nuts or milk. The survey results are summarized in the table below. Part 1 says, determine the probability that a randomly selected survey respondent is allergic to milk. So before we even get to the question, I like to add up together my categories so that I can get my total for each section and the overall total. So we know that the overall total is 1,500. And for allergic to milk, this category would be 45, and the remainder would be 1,455. And for the category allergic to nuts, it would be 15, and 1,485 not allergic to nuts. So again, let's read part 1 again. It says, determine the probability that a randomly selected survey respondent is allergic to milk. So first we have to write our probability notation. So we're going to write it as P, that would be allergic to milk. So this we're going to put over the population because it didn't give us a condition. They said randomly selected survey respondent. So from the entire survey, so we know our base is going to be 15,000. 1,500. So it's going to be 1,500. That's going to be our base. And then they say allergic to milk. So we look at a category that says allergic to milk. Allergic to milk would be this entire category right here. And so this is why it's important to take those sums. So we know that the entire category would be 45. So 45 over 1,500. And we can simplify that to 3 over 100. So that is the first part. Part 2 says, determine the probability that a randomly selected survey respondent is allergic to milk given that the person is allergic to nuts. So when we see the word given, what does it mean? Conditional probability. Basically saying, what is the probability that this event happened given that this event already happened? So they're saying the probability that they are allergic to milk given that they are allergic to nuts. Well, we'll see. So we'll write it out. Probability that they are allergic to milk given that they are allergic to nuts. And we know when we write our conditional probabilities, it's going to be the intersection. So I'm just going to put milk and nuts, they're allergic to both, over the probability of just being allergic to nuts. Okay, so the intersection over just the condition. And so when we do that and we go into our table, probability that they're allergic to milk and allergic to nuts is 3 over the total. 3 over 1,500. The probability that they're allergic to nuts in totality is 15. So 15 over 1,500. And when we simplify, that equals 3 over 15. In other words, 1/5. So the probability that they're allergic to milk, given that they're allergic to nuts, equals 1/5. Again, this was our condition, and this is what we are looking for. So what is the probability that someone has an allergy to milk when they already have an allergy to nuts? That's what it was asking. Now for part 3, this is the last part. It says, based on the survey data, determine whether nut allergies and milk allergies are independent events. Justify your answer. So there's 2 ways to test independence. We can test it with intersection, or we can test it with conditional probability. The best option to use in this question is conditional. Why, you may ask? Because the entire two parts here is setting us up for this question. Because in order to test conditional probability and see if events are independent, you're seeing whether the probability of being allergic to milk is equal to the probability of being allergic to milk, given that you already have a nut allergy. So if we go back, we know that the probability of being allergic to milk is what? 3 over 100. And the probability of being allergic to milk, given that you're allergic to nuts, is 1/5. And we know that is not equal to each other. So because these two events are not equal to each other, they are not independent. And we would make the statement, and we'll say that, I'm going to make the statement from the beginning, so we'll say that nut allergies and milk allergies are not independent events because the probability of having a milk allergy is 3 over 100. You could add decimal form as well, which is not equal to the probability of having a milk allergy given being allergic to nuts. Let's see. Which is not equal to the probability of having a milk allergy of 1 over 5, 1/5, 0.2. So because the probabilities are not the same, these events are not independent. Not independent. Okay, now, the second way that you could have done this, and again, I prefer you to use this way, the conditional probability. Conditional probability helps more because they already give it to you, and so it's easier for you to get the points. But if we were to do a different question and it would also ask you about conditional probability independence, you could also use intersection. But what I mean is that the probability of events, so of being allergic to milk and nuts, is equal to the probability of having a milk allergy times probability of having a nut allergy. So if you look back at our table, we know that the probability of being allergic to nuts and milk is 3 over 1,500. And the probability of being allergic to milk, is 45. Probability of being allergic to milk is 45 over 1,500. Probability of being allergic to nuts is 15 over 1,500. (3e to the negative 4). And that is not equal to 3 over 1,500. Question 34 says, algebraically solve for x. 2x equals 6 plus 2 square root of x minus 1. So, first things first. Question may look very straightforward. It is very straightforward, but there's one part that you cannot miss, and if you miss it, you will not get full credit. So first things first, I'm going to subtract 6 on both sides. So you get 2x minus 6 equals 2 square root of x minus 1. Next thing that I can do is divided by 2 on both sides, so x minus 3 equals square root of x minus 1. I can square both sides so that I end up getting x squared minus 6x plus 9 equals x minus 1. And then I subtract x on both sides, add 1 on both sides, and I get x squared minus 7x plus 10 equals 0. Now to find the values of x, what I can do is I can factor. So I like doing the x method. So what two numbers multiply to get 10 and add to get negative 7? Well, we can use negative 2 and negative 5. So we write that as x minus 5, x minus 2, set that equal to 0. So our x minus 5 equals 0, add 5 to both sides. X minus 2 equals 0, add 2 to both sides. So x can either be 5 or can be 2. Now, if you put both of these answers, you will not get full credit. Here's why. You need to test whether one of these solutions is extraneous. So what I mean by that is we have to substitute it back into our equation. So our equation says, so we're going to check. Let's do x equals 5 here and x equals 2 here. So our original equation was 2x equals 6 plus 2 square root of x minus 1. So we just plug it in. So 2 times 5 equals 6 plus 2 square root of 5 minus 1. So that is 10 equal to 6 plus 2 square root of 4. That is just 10 equals 6 plus 2 times 2. 10 equals 6 plus 4. 10 equals 10. So we know x equals 5 works. So we know this checks off as a solution. Now let's try x equals 2. So we plug it in. 2x equals 6 plus 2 square root of x minus 1. So we plug it in. 2 times 2 equals 6 plus 2 square root of 2 minus 1. So that is 4 equals 6 plus 2 square root of 1. 4 equals 6 plus 2 times 1. 4 equals 6 plus 2. 4 equals 8. Nope, does not work. This is extraneous. So our final answer will say that we're going to reject this, accept this. So let me write it again. X equals 2, reject. X equals 5, we accept. And x equals 5 is our final answer for this question. So again, this question is straightforward. However, if you forget to check your work, being that we are in Algebra 2, you will get it wrong because there are solutions that are extraneous. Okay? Question number 35. During the summer, Adam saved $4,000 and Betty saved $3,500. Adam deposited his money in Bank A at an annual rate of 2.4% compounded monthly. Betty deposited her money in Bank B at an annual rate of 4% compounded quarterly. Write two functions that represent the value of each amount after 2 years if no other deposits or withdrawals are made. Where Adam's account value is represented by AT and Betty's by BT. So we're using our compounded formulas. So again, to remember what we said, our compounded formulas are, we have A equals P 1 plus r over n and nt. So r is the annual rate, n is the time, like whether it's monthly, quarterly, yearly, annually, and then t is just the time or how long it takes. And so we rewrite this for Adam with AT and Betty for BT. So let's start with Adam. Adam's initial rate was $4,000, his initial amount. 1 plus, and he uses a bank that has an annual rate of 2.4% compounded monthly. So we know that our rate is 0.024 monthly, so it's over 12 months. Okay? We close out our parentheses, and again it's 12 because it's monthly t, and when we simplify that, that is going to be 4,000 1.00212t. And then for Betty, we're going to do the same thing. So her initial amount was 3,500. It's 1 plus, she's using a bank that does an annual rate of 4% compounded quarterly. So we're going to do 0.04 divided by 4 because it is quarterly. Quarterly is 4s. And then we're going to close this out, and we're going to do 4t. And when we rewrite this, it's going to be 3,500. And then we're going to do 1.014t. And that is the first part. We're just writing the equations for both Adam and Betty. And make sure you use the correct notation that they give you. They told you Adam's AT, Betty BT. Use AT for Adam, BT for Betty. Now the next part says, using technology, determine to the nearest tenth of a year how long it will take for the two accounts to have the same amount of money in them. Justify your answer. So it tells us to use what? Use technology. So what we're going to do, we're going to go into our calculator. We're going to type in both equations. Graph. After we click graph and we get our graphs, if we can't see them, change your windows and zoom out. After doing that, we're going to do second trace. We're going to go down to the one that says intersect because we were trying to see when they have the same amount of money. So you're going to go to intersect. You're going to do your first curve, your second curve, and then you're going to go to guess. You're going to estimate where that intersection is. That's going to give you your answer. Your x is going to be x equals 8.43785, and your y is going to be 4896.89. And you're going to, because it says justify, we're going to do a rough sketch of what it looks like. So we have our lines and they intersect here, and this is our point. And so we'll say that it will take both accounts 8.4 years to have the same amount of money. So we gave our justification because we use it on the calculator. We're going to graph it. So we just say graph roughly from calculator. And we give our justification, we write our x and y, and we give our statements. Question number 36 says, on the graph below, draw at least one complete cycle of a sine graph passing through point 02 that has an amplitude of 3, a period of pi, and a midline at y equals 2. So we have our midline, we have our amplitude, we have our period, and we have a point. So first things first, we're going to remember that a sine graph follows this order. it goes midline, max, midline, min, midline. That would be one period. Okay? That's how it goes. Midline, max, midline, min, midline. This is what it's supposed to look like. That would be a sign graph. So, it tells us that our midline is at y equals 2. So, it's right here. This is our midline. Okay? We can draw it out. This is our midline. Midline at y equals 2. And it must pass through the point 0, 2. It has an amplitude of 3. That means the distance from the midline to the max is 3. So if we're at our point, which is in the midline, we're going to go up 3. 1, 2, 3. And right here is going to be our maximum. And this is why I'm moving it over here. Because we're going what? Mid-max. And it says what? A period of pi. So our entire period ends at pi. So we are at the midline. We went to the max. We go back to our midline here. We want to find our min. We're going to go 3 down from where? From the midline. So 1, 2, 3. Here's our min. And we go back to our midline. And we have a period of pi. Because look, it ends at pi. We can do another one. We do the same thing. So we're at the midline. We go to our max. Go back to the midline. To the min. To the mid. And that would be another one. That would be another period. Okay? And you could also do them on the other side. And so this would give us 4 points. And we could also write the equation. And it's helpful when we write the equation. So our equation would be y equals 3 sine 2x plus 2. So when we go from 0, this is 0, to pi over 4, this is pi over 4. Right here, this is pi over 4. We're increasing. So one of our intervals would be from 0 to pi over 4. Where you see it increasing, so from, for example, from here to here, that would be an example of an increase. Here to here would be an example of an increase. From here to here, that's an example of an increase. Wherever you see an example of an increase, that would be a valid interval to write. Now time for our last question. Question 37, which is worth 6 points. So, a manufacturer of sweatshirts finds that profits and costs fluctuate depending on the number of products created. Creating more products doesn't always increase profits because it requires additional costs such as building a larger faculty or hiring more workers. The manufacturer determines the profits, PX, in thousands of dollars as a function of the number of shirts sold X in thousands. The function P is shown below. P of X equals negative X cubed plus 11X squared minus 7X minus 69. Graph Y equals PX over the interval 0 from X is greater than or equal to 0 to 9 is greater than or equal to X. So, to do this, we're going to go into our calculators. We're going to type in our equation into y1. After we type in our equation, we're going to do second graph. And we're going to go to the table of values that we get from where? From 0 to 9, because that's what they asked for, from 0 to 9. And we're going to write down those values. So we have X and we have Y. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And these are the values that we should have. So these are the values that we should have. I'm just retouching so that you guys can see it better. Now what are we going to do? We're going to go to our graph and we're going to graph it. So the first value that we have is 0, negative 69. So we estimate. So here's 0. This would be 30. This would be 60. And then this would be 90. This would be 75. So it's around somewhere right here. This is where it's going to be, right? Move it up just a little bit. And then 1 is going to be at 66, so it has to be a little bit above negative 66. 2 is going to be at 47, so we said this is 30, this is 45, so this would be 47. And then our 3 is at 18, so we know this is 15 since this is 30. So we're going to go to right here. And then our 4 is at 15, so right here. And then our 5 is at 46, so we know right here is 45, so 46 will be right here. 6 is at 69, so we know that this is 45, 60, so 69 is just going to be a little bit above. And then we know 7 is going to be 78, so we know this is 75, so this would be 78. And then 8 is at 67, so as we said, this is 60, so 67 would be a little bit above. And then 9 is at 30. And we're going to connect our dots to form our graph. And key thing to remember, do not put arrows on your graph. Do not put arrows on your graph. You're going to be like, oh, Haneen, why not put arrows? Because look, it says over the interval from 0 to 9. So that means that our graph does not extend anymore. Okay, so that is going to be the first part. Next part says, over the given interval, state the coordinates of the maximum of P and round all values to the nearest integer. Explain what this point represents in terms of sweatshirts sold and profit. So, if we look back and see, our maximum point is going to be the biggest point where it goes high and then it shifts down low. And we know this part hits where? It's at 7 and 78. Right? So, because this is when it's rounded. This answer is when it's rounded. So the calculator did the rounding for us. So we go back to our question and we say that the coordinates, we just wrote the coordinates of maximum are 778, and we explain it. So we're saying if the company sells 7,000 sweatshirts, the maximum profits is $78,000. Okay? Why did I say 7,000, 78,000? Because in the problem, it said that t-shirts were in terms of thousands, and so were the profit prices. So that would give us that point for this part. Last part says, determine how many sweatshirts to the nearest whole sweatshirt a manufacturer would need to produce in order to first make a positive profit. Justify your answer. So, for this question, we're going to go back into our calculators and we're going to look at where y equals 0. In other words, we're going to look at our roots for the graph. And to find our roots even more accurately, we can trace them. So click second trace, and you'll click roots or zeros, and then you're gonna go. You have to pick the roots where it's in the positive end of the x-axis. So you have to find the roots that is here, because you're gonna have a roots here, a root here, and a root here. I'm just mimicking what the graph. You have a root here, and a root here. You want this root right here. Why? Because this is the first root where the profit is going to be positive. This root right here, negative. Ignore that. This one, it's hit already, the positive. We need to focus on this root. So when we find this root on our calculator, we're going to get its value to be 3.5488. 3980. This is going to be the root. And so again, we use y equals to find the roots for the graph. The roots for the graph. And we get the x to be 3.5488398. So we have that. Now, is that our answer? No, because we said what? Sweatshirts are in thousands. So to the nearest whole, so the manufacturer would need 4,000 shirts to make the first positive profit. Because, here's our justification. Why we said this? Because the first positive root of our equation, P of x, is at 3.5488398. And rounding that and round it to the nearest whole is 4,000 sweatshirts. Okay? And with that, we conclude the January 2024 Algebra 2 Regents. I thank you for staying this long with me in these videos. Make sure to watch all of them. If you have any questions, write comments and let me know. I will be sure to go back and respond to any of the questions you have. And with that being said, make sure you like, share, and subscribe. Comment down below any questions, any suggestions. Share with all your friends. And good luck on your test on June 24th. Remember, it is a morning exam. So be there at your school whenever they told you. Morning exam. So sleep tight, get a good night rest, eat breakfast, drink water, have all your supplies ready. Make sure you have pencils, pen, change the batteries to your graphing calculators, and good luck on your test. And thank you for watching this video. Bye.